Hello everyone. This video is going to explain all the objectives related to our first chapter, the sets. Our objectives are first to characterize a set, the element of a set, and the subset of a set. We are going to write a set in extension and in comprehension form. We are going to determine the intersection and the union of two or more sets. We are going to use different diagrams to represent sets and to recognize sets of numbers that are natural, integers, rational, irrational, and real numbers. So let us first define what's a set and an element. Any collection of objects is a set, and the objects contained in a set are called its elements or members. The roster method defines a particular set by listing its elements separated by commas within curly brackets. For example, we have a set ABC. They are separated by a comma and within a curly brackets. The set 1, 2, 3, 4, 5. The elements of this set are 1, 2, 3, 4, and 5. And the set could be names of a human. It could be kind of animals. So cat and dog are elements of the following set. Names for a set. How can I name a set? It's conventional to use capital letters for names of sets. For example, letter S is a set that contains ABC. A is a set. 1, 2, 3, 4, 5 are the elements of the set. T, capital T, is a set that contains Mo, Larry, and Curly as elements. Also, B is a set that contains cat and dog. Referring to these sets, the set S that contains ABC and the set T that contains Mo, Larry, and Curly, we observe, for example, that A is an element of S and Larry is an element of T. These statements are denoted symbolically as follows. We say A belong to S. Belong is represented as E. Mo does not belong to S. So if an element is not found in a given set, we say that this element does not belong to this set. We say that Larry belongs to T, but B does not belong to T. Now let us define together the cardinality. The cardinality of a set is the number of elements contained in that set. For example, we have the set S that contains ABC and the set B that contains dog and cat. Then the cardinality of S is 3 and the cardinality of B is 2. These facts are denoted symbolically as follows. N of S, when I say N of S, mean cardinality of S is 3 equals 3 and the cardinality of B equals 2. The set equality. Two sets are equal if they contain exactly the same elements. For example, 1, 2, 3, 4, 5 is equal to 5, 3, 1, 4, 2. I don't care about the order of the elements. I only care about the elements contained in this set. Mo Larry is equal to Mo Larry. The same elements are found in both sets, so the two sets are equal. B, C, A is equal to S. However, 1, 2, 3, 4, 5 is not equal A, B, C, D, E. although they have the same number of elements, but the elements are not the same. Subsets. Suppose V is a set, and W is a set that's formed using only the elements of V. That's W can be formed entirely by including or excluding elements of V. We say that W is a subset of V, and it's symbolically written as follows. This is how I say that a set is a subset of another set. Let us take an example. T, which is Mo, Larry, and Curly. List all the subsets of T. I'm going to write Mo alone is a set. Larry alone is a set. Also, Curly alone is a set. I can put Mo and Larry together. Mo and Curly together. Larry and Curly together. Mo, Larry, and Curly together. So these are the subsets of T. And don't forget that empty set is a subset of any set. Examples, let us solve the following as a true or false. B, H, R, Q are subset of H and R. This is false. The opposite is true. HR is a subset of BHRQ. 3, 12, 5, and 19 is a subset of the following set. Let us check. 3 is found, 5 is found, 12, 19, so 3, 12, 5, 19 are found in this set. So yes, this set is subset of the second set. Let us see the third example, A, 13, D, and 2. Is this a subset of 13, 2, D, and A? A set could be subset of itself, so yes, this is true. What's the universal set? Universal set is larger set that contains at least all the elements of all other sets in the discussion. Example. This is the universal set that contains the following names. T is a subset of U. List all the elements that aren't in T. So, what are the elements that are found in U, but they are not found in T? Champ, Carly, and Joe. So we say that this is the complement of D, and it's denoted by T bar. Sorry. So when I say complement or bar of T, I mean all the elements that are found in the universal set, but they are not found in T. Now let us talk about the set builder notation. Set builder notation is a way of defining a set by describing its elements rather than listing them. So instead of listing the elements, I'm going to describe them. For example, A, B, C, D, E, F. I can say that it consists of 6 letters, 4 of which are consonant and 2 of which are vowels. But how this is written? Look at this example. I say that C is a set, contains elements X, where X is a consonant. So the set of all X are consonant. So I can write, for example, B, C, D, F. Whereas V is the set of all X such that X is a vowel. So I can choose A and E. Exercises. Let U that contains the natural numbers from 1 to 10. A is 3 and 5, E 2, 4, 6, 8, 10. X is an odd number. True or false? E belongs, or E bar belongs or equals to F. Let us find E bar. E bar are all the elements that are found in U, but they are not found in E. So they are 1, 3, 5, 7, and 9. This is E bar. Okay? So is E bar equals to F? Let us find all the odd numbers. 1, 3, 5, 7, and 9. Now if I just look at the elements, they are the same in both E bar and F. So yes, this is true. Let us continue. Is F a subset of A? Are the elements of F found in A? This is not true because not all the elements are found there. Where A is a subset of F, by the way. We say that 1, 2, 3 is a subset of 2, 3, 5, 6. This is not true because when I say subset, all the elements that are found in the first set should be found in the second set. Now, is 4, 7 a subset of 4, 7? Yes, this is true because a set is a subset of itself. Now, let us see how can I find the number of subsets in a finite set. So how can I know the total number of sets or subsets that I can form? So every time you need to find the subset, you have to calculate 2 to the power of k, where k is the number of elements, and 2 to the power k minus 1 for proper subsets. Now, how can I represent a set? A set can be represented by a closed domain in which the elements are listed. It's called the Venn diagram. So for example, this set E contains 1, 2, 3, 4, and 5. If you look at the first diagram, this one, it talks about the set A. And this diagram represents the set B. If I colored all the following circles, I mean A union B. What's the meaning of union? All these elements that are found in A or in B, so all of them together. So what's the bar of A union B? Is all these elements that are not found in A and not found in B. So the elements are everything around the two sets. Those are some representations that you are going to be familiar with later on. Now I'm going to define what's the meaning of an intersection and what's the meaning of union of two sets. When I say the intersection of two sets, A and B, I mean all the set containing those elements which are found in A and found in B together. So all the elements that are found in A and B together, so we write it A intersection B. Example, I have the set A 3, 4, 6, 8 and the set B 1, 2, 3, 5, 6. Then the intersection of the two sets is 3 and 6. If A is the set of prime numbers and B is the set of even numbers, then A intersection B is only 2. But if A is all the numbers that are greater than 5 and B are all the numbers that are less than 3, then A intersection B is 5. 5 means nothing. I can't find an intersection. Now let us talk about the union of two sets. When I say union, I mean elements of A or elements of B. It could be in A or it could be in B. So I write it as A union B. Example, if I have 3, 4, 6 in A, 1, 2, 3, 5, 6 in B, then A union B are all the elements together, 1, 2, 3, 4, 5, and 6 together. Now we are going to take some properties concerning the union and the intersection. You have to know that union and intersection are commutative operations. When I say commutative, mean A union B is the same as B union A, and A intersection B is the same for B intersection A. When I say A union B union C, it's the same as if you calculate the union of B and C, then you find the union with A. So it's also associative. Associative means you can change the brackets. Okay? You have also to know that it's distributive law. So I can say that A intersection B union A intersection C. So that's what I mean when I say distributive laws. Let us talk about some properties. A in union phi is A, that phi will never make a change. A intersection phi is phi. In the intersection, it will make a change. A union A is A, and A intersection A is A itself. Sets of numbers, you have to remember that a natural number are all the positive integers only. When I say and star, I mean all the positive integers but excluding the zero. Integer numbers they could be negative and positive numbers, whereas the natural number only the positive numbers. So I can say that n is a subset of z. The same thing when I say z plus, I mean the natural numbers only. When I say z minus, I need all the negative numbers in z. Z star are all the integers but excluding 0. Also, the real numbers, or the rational and irrational. The real numbers are everything from minus infinity till plus infinity. Examples: radical 2, radical 3, radical 5, pi, radical pi 2, 4, half, minus 10. All these are real numbers. And decimal numbers are numbers that are fine, yani they never have periodic or repeated numbers. For example, 0.05 is a decimal. It's a limited decimal. That's what I wanted to say. It's a limited decimal. It's not periodic or bar that never ends. Okay? Whereas rational numbers are the unlimited or the repeated decimals. Okay?